For decades, Russian air defense systems have carried a reputation for strength and resilience. Names like the S-300 and S-400 became symbols of layered protection, designed to deny entire regions of airspace to enemy aircraft and missiles. But modern warfare is changing. Precision strikes, long-range drones, and saturation attacks have begun to challenge even the most advanced defenses. At the center of this shift is the S-350 Vityaz, one of Russia's newest air defense systems, created to protect against the threats of the 21st century and now tested under the harsh realities of war in Ukraine. The S-350 was born from a problem Russia could no longer ignore. By the early 2000s, many of its air defense units relied on aging S-300 variants designed during the Cold War. While powerful, these systems were not optimized for modern threats like small drones, cruise missiles, or large numbers of simultaneous targets. Russian military planners recognized that future conflicts would not be defined by single high-value aircraft, but by waves of cheaper, faster, and harder-to-detect weapons. The S-350 was designed to fill this gap, not as a replacement for long-range systems like the S-400, but as a highly efficient medium-range shield, capable of defending key areas against saturation attacks.
The S-350 Vityaz air defense missile system is a medium-range ADMS that is designed to protect administrative, industrial, and military facilities from massive strikes by modern and prospective air attack weapons such as tactical and strategical aircraft, cruise missiles, helicopters, UAVs, air-launched weapons, tactical and operational tactical ballistic missiles.
Development of the S-350 was led by Almaz-Antey, Russia's primary air defense manufacturer. The system was publicly revealed in the mid-2010s and officially entered service around 2019. Unlike earlier systems that emphasized sheer missile size and range, the S-350 focused on flexibility and volume of fire. Each launcher carries more missiles than older platforms, allowing it to engage many targets without frequent reloading. However, production has never been rapid. Western sanctions, supply chain limitations, and the technical complexity of modern radar systems have constrained output. As a result, the S-350 remains relatively rare compared to older Soviet-era systems still in service.
The ADMS is capable of engaging aerodynamic targets at the ranges of up to 120 kilometers, ballistic targets at the ranges of from 5 to 25 kilometers. The altitude of aerodynamic targets engagement is from 10 meters to 25 kilometers, ballistic targets from 2 to 20 kilometers. The maximum speed of engaged targets is 2,000 meters per second. The number of simultaneously fired targets is 16 aerodynamic or 12 ballistic targets.
At its core, the S-350 is built around a modern, digitally networked architecture. Its radar uses active electronically scanned array technology, allowing it to track dozens of targets simultaneously while guiding multiple interceptors at once. The system primarily uses the 9M96 family of missiles, originally developed for the S-400, as well as smaller interceptors designed for close-range threats. Depending on the missile type, engagement ranges can extend to roughly 120 kilometers. What sets the S-350 apart is efficiency. Instead of relying on a few large interceptors, it uses many smaller, highly maneuverable missiles, making it better suited to counter-drones, cruise missiles, and precision-guided weapons.
Aerial reconnaissance is carried out using a multifunctional radar or auxiliary radar means. The maximum target detection range is 150 kilometers in circular rotation mode or 230 kilometers with the fixed antenna mode. Multifunctional radar carries out combat operations fully automatically without the participation of the operator, under the remote control from the combat control post. When firing at air targets, multifunctional radar tracks up to 8 aerodynamic targets or 6 ballistic.
When Russia launched its full-scale invasion of Ukraine, the S-350 was not immediately visible on the front lines. Early in the conflict, it appears to have been reserved for protecting strategic rear area targets, including infrastructure, logistics hubs, and high-value military sites. As the war progressed, Ukraine expanded its ability to strike deeper behind Russian lines using long-range drones and precision weapons. This shift gradually pulled advanced air defense systems, including the S-350, closer to contested zones. What was once considered relatively safe airspace began to disappear, forcing Russia to deploy even its newest systems under increasing pressure. Exact numbers remain unknown, but most analysts agree the S-350 is limited in quantity. Estimates suggest only dozens of systems, not hundreds, are currently operational. This scarcity matters. Each S-350 battery represents advanced technology, long production timelines, and significant cost. Unlike older systems pulled from large Cold War stockpiles, the S-350 cannot be easily replaced. As a result, every deployment decision carries risk, and every loss carries weight.
The launcher is designed for the transportation, storage, automatic pre-launch preparation, and launch of SAMs. SAMs have active homing heads and are placed in transport and launch containers. One launcher can accommodate 12 surface-to-air missiles. The ADMS also includes launchers and loaders, designed, among other things, for loading and unloading SAMs to launchers and launcher loaders, and carrying out loading and unloading operations with transport and launch containers.
Recently, reports and imagery emerged indicating the first confirmed destruction of an S-350 system, reportedly struck by a Ukrainian drone. While details remain limited, the event marked an important moment. The loss demonstrated that even modern, well-defended systems are vulnerable to low-cost, persistent aerial threats. It also highlighted a growing imbalance in modern warfare, where relatively inexpensive drones can threaten systems worth tens of millions of dollars. For air defense planners on both sides, the message was clear. Technology alone does not guarantee protection.
A unique feature of the air defense missile system is the ability to simultaneously repel attacks from various types of air attack weapons, flying from any direction in the entire range of their flight altitudes, from extremely low to high. Now the combat crew will repel the mass attack of the enemy. Both aerodynamic and ballistic targets will be flying at us from any directions. There is the mass attack of the enemy. 97 L6E radar detects the targets. One multifunctional radar operates in the circular mode and another operates in the sector mode. The ballistic targets are entering their engagement zone. Vityaz ADMS is engaging ballistic targets. Now Vityaz ADMS is going to engage aerodynamic targets. Now all the targets are successfully engaged.
The war in Ukraine has become a proving ground for modern military systems, not in controlled tests, but under constant pressure, adaptation, and innovation. Weapons once considered cutting-edge are being tested against tactics that evolve in real time. The S-350 now occupies an uncertain place in this conflict. It remains a capable and modern air defense system, but one operating in an environment where no area is truly safe, and where threats are increasingly cheap, numerous, and unpredictable. More broadly, the conflict has shown that air defense is no longer about building an impenetrable shield. It is about managing risk, conserving resources, and adapting faster than the opponent. In that sense, the story of the S-350 is not just about one system, it is about how modern warfare is redefining the balance between offense and defense, and how even the most advanced technology must constantly evolve to survive.